day to you viewers, the Colonel speaking to you live from the Grange of British Imperial YouTube Broadcasting. Now we've got a very unusual record here, hopefully you can see it. It's G. Marconi Special record, MC1, Electrical Interference with Broadcast Reception parts. Well, we're going to do parts 1 and 2, turn it over. This is where some strange bloke tells you, well, I suppose these records were issued to sort of Marconiphone dealers who took a very expensive radiogram to a new home, only for the owner to have interference with the signals. Yes, and this is how they trace them. It sounds awfully boring, but it's actually highly amusing, because they play excerpts from very grand records with lots of different types of interference. My word, it's interesting, isn't it, viewers? These are from the Roger Thorne collection. I didn't buy them from the auction though. Here we go.
These records have been made with the idea of giving you some standards on which interference with broadcast programs can be judged and traced. The examples have been chosen by Marconi men to indicate the most common types of interference, but the exact form of any one type will be governed largely by local conditions. To identify an interfering noise, therefore, pick out its chief characteristics and refer to the table on page 12 of the Marconiphone Manual on Interference. Select the appropriate record and play it on a radio gramophone with the tone control set at the normal position. Set the volume control so that about the same level of sound is coming from the radio gramophone as from the receiver being affected. If there is a similarity between the interference heard from the receiver and that from the record, it is safe to look for a source of interference of the same type as that named on the appropriate page of the manual. The cure will then be as described on that page. This first side illustrates the interference to a broadcast program which may occur when an electric bell, medical apparatus, or ignition device is being operated near the receiver. Here is the noise caused by an electric bell being rung near the receiver. There is, as you heard, a regular sputter whenever the bell is rung. Listen again. Bell interference can be suppressed by condensers connected as described on page 14 of the Marconiphone Manual. Violet ray apparatus gives rise to very severe interference indeed. Here is the interference caused by such apparatus starting during reception. Note the regular coarse grating which varies in intensity as the electrode is passed over the patient's body. Listen to that once more. That noise is generally typical of interference arising from diathermy apparatus, X-ray installations and high-frequency plant in general. Such apparatus radiates interference directly at great intensity and also gives rise to the more general mains-propagated form of interference, which can be suppressed by a filter circuit connected in the mains, as shown in the diagram on page 16 of the Marconiphone Manual. The directly radiated interference can be suppressed only by enclosing the apparatus and any person operating it or receiving treatment in a room which is completely surrounded by a screen of earthed metallic netting to which all electric wiring and conductors, such as gas and water pipes entering the enclosure, must be connected as shown on page 16 of the manual. Electrical ignition systems used on oil burning plants for boiler heating, etc., give rise to interference which is somewhat similar in character. Here is a reproduction of it. Note the similarity of this interference to that caused by the violet ray apparatus. Listen to the coarse grating again. Such interference is directly radiated over short distances and mains propagated over a considerable area. It can be suppressed by connecting a filter circuit in the mains lead, supplying current to the high tension unit on the oil burner. This method is shown in detail on page 17 of the manual.
Right, over to the other side for more interference, viewers. I thought some of that old biddy singing was actually improved by the interference, but there you go. Typical. Here we go.
The ignition system of motor car engines or other internal combustion engines, whether of the magneto or induction coil type, may cause interference which sounds like this. The series of rhythmic plops which you heard occur whenever there is a spark at the contact breaker and plug points. Listen again to another example. The dynamo which charges the car battery may also give rise to interference, the combined result sounding like this. That was dynamo and ignition interference combined. Listen to them once more and note the faint whining due to the dynamo. Such interference is rarely audible except on very short waves, unless the receiver is used in or very near the motor car. Several methods of suppression can be utilized for the ignition system, and they are described on page 29 of the Marconiphone manual. The dynamo can be rendered non-interfering by connecting condensers to it as described on page 19. Neon signs in which the tubes give a red light may give rise to interference, such as you will now hear interrupting a radio program. Listen to the program and note the interference caused by the sign when it is switched on. You hear a low note on which are superimposed notes of a much higher frequency. Here it is again. The interference which you have just heard arises from the luminous tube circuits. If the sign is supplied with current from a converter, this machine also may give rise to interference, and when both forms of interference are present, the combined result sounds like this. That was typical of interference caused by both the neon tube circuits and the converter. Listen to it again. The interference caused by such a sign may be directly radiated over short distance and mains propagated to a much greater range. Both forms can be suppressed by inserting suitably designed choker coils in each of the neon tube circuits causing trouble. These should be connected as nearly as possible at the electrical center of each tube circuit. See page 18. The converter can be rendered innocuous by means of filter circuits which should be connected to it in the manner detailed on page 22. Similar noise may be caused by ozonators, the interference from which may be propagated for several miles along the supply mains. See page 28 of the Marconiphone manual.
That's most extraordinary, viewers, and it's something we don't notice today, apparently. I was talking to Squire about this. He's rather knowledgeable about radio matters and wireless, and he tells me that, of course, most things are insulated nowadays, or I forget the term he used, actually, a technical term. But in the 20s, this is 1934, this record, and the others, in those days they weren't, and the squire was telling me in the 60s, if a car drove past his farmhouse, which was several hundred yards away from the high road, the television signal would be affected, or if a plane went over. But of course nowadays we don't know we're born, do we, viewers? Thank you, viewers. On to the next one.